This is a key to the word problems from the section dealing with applications. And these four problems deal with these two objectives that you see here. Use a formula to solve real world application or geometry problem. And then the second one is translate verbal expressions into mathematical expressions. Now make sure you always follow the directions. The direction says for each problem, indicate the unknowns in the expressions, set up the equation, solve, and answer the question using a complete sentence. So let's look at number one. So number one, you're told that on Monday it took Dave 4.5 hours to drive to his friend's house. And then on Tuesday, when he was returning home, it took Dave 5 hours to return home. His speed was 4 miles per hour slower on Tuesday than on Monday. What was his speed on Tuesday? All right, so the formula you're going to use in number one is that distance is equal to rate times time. So that's going to be the formula you're going to use in this particular case. So distance equals rate times time. Now, in this particular problem, there are two situations occurring with regards to distance, rate, and time. There is a situation where Dave is driving to his friend's house, and then there's a situation where Dave is returning home. So there are two instances of using this formula. And so since that's the case, we're going to set this up using a table to help us to uh, set up our information, to understand our information, and then to set up an equation. So this table is just a way of organizing our information. So we're going to use a table. And so we know that in this table, we know that distance, d, is equal to rate, and then times time, just like this. All right. So you have this column distance, this column rate, this column time. Notice how I'm writing the formula out above the table. Distance equals rate times time. Okay. And notice there are two iterations of this formula that will be used. So in this case, I'm going to use two rows. There is a situation where he is going to his friend's house on Monday, right? So he's driving to his friend's house on Monday. And then there's a situation on Tuesday where he is driving home. So I'm going to put in parentheses driving home. And over here you could say on Monday, going to friend's house, going to friend, something like that. Okay, now here's what else you know. And so we need to fill out as much of these cells as possible, enough of these boxes as possible. Okay. One of the things you know in the problem is that it took Dave 4.5 hours to drive to his friend's house. So that's a known fact, right? So the time, that's time there. So time is 4.5 hours. 4.5 hours. Okay? And then on Tuesday, it took Dave 5 hours to return home. So right away, we know what the time is on Tuesday. So that time column is pretty easy. We already did that part. That was quick. All right. And then it says, now the next sentence says that his speed, when he returned home, his speed, which is the rate, so rate is the speed, is 4 miles per hour slower on Tuesday than on Monday. And the question is, what is his speed on Tuesday? Okay, so it's his speed on Tuesday. So so what we need to think about is this. Notice this statement here. We have to let you're looking for speed, right? And in particular, looking for his speed on Tuesday. So we need to let the variable, in this case we'll call it x, be either the speed on Monday or the speed on Tuesday. To determine that, look at what you're told. You're told that his speed was 4 miles per hour slower on Tuesday than on Monday. So another way we can write this is that on Tuesday, his speed was 4 miles per hour. I'm going to write it like this: 4 miles per hour slower than on Monday. Okay? So his speed on Tuesday, his speed was 4 miles per hour slower than on Monday. So if you look at that statement, his Tuesday speed is based on something known about his Monday speed. His Tuesday speed is based on something known about his Monday speed. So I'm going to let x equal his Monday speed. And now once I let x equal the speed on Monday, so I'm going to actually write it out, let x equal the speed on Monday. Because remember the directions that say indicate the variables and the unknowns. So the one of the unknowns is at his speed on Monday, so we're going to let that be x. And then on Tuesday, here's what you know about his speed. You know that his speed on Tuesday is slower than it was on Monday, right? It's slower. And notice though that you have to be careful when you use subtraction. Subtraction is not commutative. The order in which you subtract does matter. So let's say his speed on Monday is 50 miles an hour. Then what was his speed on Tuesday be? It says 4 miles per hour slower, right? So it'll be what? So if this is 50, then this has to be what? 46, because it's 4 miles per hour slower. So how'd you get 46 here? You said 50 minus 4. 50 minus 4. Minus 4, right? So it's whatever this speed is minus 4. So the way to represent Tuesday's speed is to say x minus 4. So his speed on Tuesday is x minus 4. All right. And then now, all you have left is this column right here. And we're going to fill this part in using our formula. So if we know the rate and we know the time, then we know the distance on Monday. So distance on Monday is 4.5 times x. So 4.5 hours times his speed. And then the distance on Tuesday is the same thing. The time times his speed. So it'll be 5 times x minus 4. Okay, so I filled out that table, I've organized it, and then I need to come up with an equation. And the way to come up with the equation is to notice something about the distances that he drove. What is the distance? Compare now the distances between going to his friend's house and then coming back home, and assuming he took the same path. Well, I kind of gave it away by saying same path, right? So what do you notice about the distances? What can you say about the distances here? Those distances have to be equal to each other, right? So note the distance to friend's house has to equal distance going home. Now again, that's assume he takes no other route. We're assuming that in this situation. Okay, so let's set up the equation. So what is the distance going to his friend's house? It is represented as 4.5x. Equal. What is the distance going home? Well, it's expressed as 5 times x minus 4. And so there's the equation. And so you solve for x, and then you can answer the question, and all they want to know is, what is the speed on Tuesday? That's all this problem asks you to find. Okay, so setting up this, solving this linear equation, we have 4.5x equals 5x minus 20, right? And then subtracting 5x from both sides. 4.5x minus 5x is a negative 0.5x equal, and then that's going to be negative 20. Divide both sides by negative 0.5. Negative 0.5, now not x. And then reducing, I get x to be. And when I use a calculator for this, Remember, a negative divided by negative is a positive. 20 divided by 0.5 or 20 divided by half is 40, right? So x is 40 miles per hour. Now be careful. You always have to come up with the with a statement to answer the question. The question is, what is the speed on Tuesday? You need to be careful. Is x's speed on Tuesday? No. X represented what? His speed on Monday. All right? So his speed on Tuesday is this number minus 4. Oops, sorry, right here, right here. This number minus 4. All right. So Dave's speed on Tuesday is, and then you're going to say, and you could come here and, well, let's do it right here, is going to be 40 minus 4, which equals 36 miles per hour. Don't just put 36, you got to say 36 miles per hour. Okay, the units are important. Make sure you include units. Include units. Okay? All right, so that was number 1. All right, let's look at number 2. So in number 2, you're told, in number 2, you're told that in a certain triangle, the measure of angle A is 4 times as big as the measure of angle C. And the measure of angle B is 60 degrees bigger than the measure of angle C. And then what is the degree measure of angle C? Sometimes it helps if you draw a diagram. And so we have a particular triangle here. So let's just draw the diagram to help us with this. And let's call this A, B, C. So the vertices are A, B, C. And in this problem, and you're talking about you're talking about angle measures here. In this problem, you're told that the measure of angle A, I'm gonna go write it out. I'm gonna put that here. The measure of angle A is means equal, right? Is 4 times as big. So that means 4 times, right? 4 times as big as the measure of angle C. So that's what that first statement says. The measure of angle A is 4 times the measure of angle C. Then it says this, the measure of angle B, is equal 60 degrees bigger than, so what does that mean? What operation is that, 60 degrees bigger? That's addition. So 60 plus the measure of angle C. Okay? Now so remember you're going to have to let x represent something here. So I wrote this to kind of help us to determine what we're going to let x be. You can let x be any of these angles, but you want to make things so much easier on yourself. Look at what we have here. Angle A and angle B are represented in terms of what angle? Angle C. So what you want to do then to make this so much easier on yourself is let x be the measure of angle C. Since A and B are both represented in terms of angle C. If you let x be any of the others, then your equation is going to be a little bit more complicated. It makes things so much easier for you if you do that. If you let x be any of these others, then the way you write the rest of these is going to be a little bit more harder to deal with. So that's why I wrote this out like this. All right, now let's go back and put what angle A is. The measure of angle A is 4 times x. The measure of angle B is 60 plus, and what do we let measure of angle C be? X. So 60 plus x, or x plus 60. Okay? And now we're ready to set up the equation. Now one of the you're in the directions it said make sure you represent the unknown. So actually, even though you drew a diagram, actually come out and write out what you know. So you know the measure of angle C is going to be x degrees. You can just list x. The measure of angle A is 4x, and the measure of angle B is x plus 60. All right, so make sure you write this out. Okay, so let's set up the equation. What do you know about the sum of all these angle measures of a triangle? So if you add up all the angles of a triangle, what does that equal to? That equals to 360. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees, right? 180 degrees. Okay? So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. Okay, so now let's go ahead and substitute all this information into our problem. The measure of angle A is 4x. The measure of angle B, where are we? Right here, is x plus 60. And then the measure of angle C is x, right? And that's going to equal 180 degrees. And you don't have to put the degree symbol. Okay, so now solving this linear equation, combining like terms, 4x, x, and x is, what's that, 6x plus 60 equal 180. And then subtract 60 from both sides. Combine like terms, I get 6x, that's a 0 there. I get 6x equal 120. Divide both sides by 6. I get x to be, and then 120 divided by 6 is 20. Okay? All right, so x is 20. All right, now make sure you answer the question. So the question is, what is the degree measure of angle C? Well, first of all, what did x represent? X represented, there we go, the measure of angle C, right? So we already found it. So the measure of angle C is 20 degrees. So you're going to say the measure, so your answer, you're going to say the measure of angle C equals 20 degrees. And that's it. Okay? All right, so you had to use the fact that when you add up all these angles of a triangle, they add up to be 180 degrees. Okay? All right, so that was number 2. Number 3, let's look at number 3. So in number 3, it says the sum of the least and the greatest of 3 consecutive integers is 60. What are the values of the 3 integers? All right, so remember, the way you want to set this up, and there's no diagram to draw there, but the way you want to set this up is to actually, since we're dealing with 3 consecutive integers, is to say this. First consecutive integer. Second consecutive, I'm going to just abbreviate here, integer. And then third consecutive integer. All right? And then if you notice in all the problems that we've done, we always let x be the first consecutive integer. And then the next consecutive integer, for example, this is, let's say 7, then this has to be 8. And so remember, to go from 7 to 8, you add 1. So the second consecutive integer is going to be represented as x plus 1. And then the third consecutive integer, you keep adding 1 to the previous one. So x plus 1 plus another 1 will be x plus 2. And it kind of makes sense because if this is, let's say, 7, then this has to be 8, right? 7 plus 1 is 8, and this has to be 9. 7 plus 2 is 9. Okay? Now, here's what you're told now. So you have to set up an equation. The sum of the least and the greatest. So if you look at all these, then we're going to let this right here be the least, and this will be the greatest, right? So, for example, this is 7, this is 8, this is 9, then 7 is the least, and 9 is the greatest. So the sum of the least and the greatest is 60. So that's what that statement says. The sum of the least and the greatest is 60. So what's the least? Well, the least is x. What's the greatest? Well, the greatest is x plus 2. And what's the sum altogether is 60. And then they want to know what's the values of all the 3 integers. Well, there's your equation. You're going to solve this equation. So you get 2x plus 2 equals 60. Subtract 2, you get 2x equals 58. Divide both sides by 2. And then use your calculator if you have to. So you're going to say 58 divided by 2, and you should get 29. And so therefore, See, that's x. So therefore, the least is 29. The next one is 30, right? 29 plus 1. And the next one is, or the greatest in this case would be 31. So your answer, complete sentence, you're going to say the three integers are, and I love the word consecutive out, but that's fine. The three integers are 29, 30, and 31. Okay? And if you add them up, you should get 60, right? 29 plus 30 plus 31, that is not 60. So something happened there. What do we do? So let's go back and fix this. So the sum of the least and the greatest of the three consecutive integers, let's see, x plus 2 minus 58 divided by 2 is 29. Oh, okay, I'm sorry. This is correct. Those three, remember the problem said the sum of the least and the greatest. So the least, so this one and this one should have to be 60, right? Because that's what the problem said. So 29 plus 31 is 60. So always go back and make sure you read the problem carefully. So it's things like that. If you're not careful, you're gonna overthink it and then think what you have is incorrect. So it said the sum of the least and the greatest. Just make sure that has to be 60. 29 plus 31 is 60. Okay. All right, and then finally number four. Number four, one number is twice another number. If 12 is subtracted from the larger number, the result is 7 more than the smaller number. All right, so you have two numbers, and they call them larger and smaller. So let's go ahead and do that. So let's call this the smaller number and then the larger number. Okay? Smaller number and larger number. But you're told that one number is twice another number. So if we call this a smaller number, let's call that x. All right? So x would be our smaller number, then the larger number is twice that in it. So let's call that 2x. Is that fine? For example, if this is 6, then this has to be what? 12. So smaller number, larger number. And then from that statement right here, that's how we're going to represent the unknowns. So one number is twice another number. And based on that, then we know this has to be the smaller, this has to be the larger. Because if this is, let's say, 5, then this has to be 10. So 5 is smaller, 10 is larger. All right, now, to set the equation, we use this fact here. If 12 is subtracted from the larger, the result is, so that's going to be your equal sign. All right, so let's go ahead and do this part here. If 12 is subtracted from the larger, so this is a larger, 2x, and I subtract 12. Remember, subtraction, the order in which you subtract does matter. All right, so you got to say 2x minus 12, not 12 minus 2x. 2x minus 12. If 12 is subtracted from the larger, the result is the same as if the result is 7 more than the smaller number. So now that one's easy to indicate because 7 more than the smaller means to add 7. So what's the smaller? Well, the smaller is x. So it'll be x plus 7. So there's your equation. So you solve this equation, so you're going to subtract x from both sides. So I get 2x minus x is x minus 12 equal 7. Then add 12 to both sides, you get x to be 19. And you want to find the numbers. So remember, x here represent the smaller. So the smaller is 19. And then the larger is 2 times 19, which is, what's that, 38? Okay? So you're going to say in complete sentence, so you answer. You're going to say the two numbers are 19 and 38. Okay? All right, so that was the 4 word problems on topic 37, part A for that worksheet 1.